And we're back to wrap up 18-5 in our discussion of reaction mechanisms. So now some reactions will in fact take place in a single step, and those are called elementary reactions. However, and let's go ahead and graph that as well. So it's the typical energy diagram that we've used in the past. So you have energy here, you have time or reaction progress here, and you'll have your reactants, you'll have your activation energy, and it'll move on to products, and it'll look something like that. All right, that's your typical energy diagram for a reaction. But most reactions actually consist of a number of elementary steps, and collectively, those are called the reaction mechanisms. And so in that case, the energy diagram would look more like this, where you have the first step, which goes from here to here. That would be step number 1. Then you have another step that takes it from that area to this area, so that would be step number 2, and then so on and so forth from here to here approximately. Actually, we should draw that down to there. Okay, that would be step number 3, and then we have step number 4, which would take us from here all the way to the end. So that would be a 4-step process, so it looks something like that. At every peak, you would have your activated complex. In every valley, you have a new product. However, that product gets used up in the next step. So rather than call them products, because that's not what you're ending with, we actually call those intermediates. An intermediate is a product from one step that becomes a reactant in the next step. So each valley, here, 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 those are going to be the intermediates. And so all you really need to understand from this section is the fact that most reactions are multi-step. Each step is called an elementary step or an elementary reaction. What gets formed in one step and then used up in the next step is called an intermediate. And you could have a reaction mechanism that looks something like this, where if you're taking dinitrogen monoxide and splitting it into nitrogen and oxygen, it might be a 2-step process where you form this O in the first step and then it gets used up in the next step, and that would be your intermediate. And when you add up those two reactions, you have two N2Os, forming two N2s and the one O2. And that's all that you would need to know for that. All right? So, in summary, in this chapter, chapter 18, we've talked about how reactions occur. That's your collision theory. We talked about how far reactions proceed, and that would be equilibrium. We talked specifically about the equilibrium that exists with an insoluble salt or only a slightly soluble salt, the solubility product. We talked about why reactions are spontaneous in terms of the thermodynamics, the enthalpy, entropy, and free energy. And now we've talked about how we can express how fast reactions go in terms of the rate laws and the fact that many reactions take place in multiple steps. All right, this concludes Chapter 18.